Okay, in the previous session, we went through the process for the deployment of a multi-node CloudVision portal virtual appliance on ESXi using the shell-based method. Now that we have this new fresh install, we're going to go through the process of the provisioning process using zero-touch provisioning for an Arista switch. This is going to entail a couple things. We're actually going to use a vEOS switch that we created in ESXi. We will enable DHCP on the CVP server itself, which is one of the critical components for ZTP. And then we'll initiate the DHCP ZTP process. And then we will go through and import the device and onboard it and actually create a container for it and move it into that container and apply the appropriate configlets for it. So the first thing that we're going to do is actually create a vEOS switch from scratch. This is a good thing that you can do in a lab environment for self-training purposes or customer deployment modeling purposes. A little bit about the vEOS lab image that we're going to use. It doesn't have all the capabilities of a real switch mainly due to the fact that you have real hardware in the real switch, and then the vEOS is really just simulating a lot of the aspects. But short of that, you can do a good percentage of what you could do with the real switch as far as testing all the different types of configurations with VXLAN, with the routing protocols, and that sort of thing. So first thing we need to do is find the image on arista.com. There are a couple images that we need, so we'll take a look. It's actually at arista.com under support, downloads, the same place where we found the CloudVision software. So we go to vEOS lab, and the one that we're actually going to use is a vEOS version of 4.23.3m, and we need the VMDK image. What we also need is a copy of the ABoot ISO, which serves as the base firmware for all of our switches. So we've downloaded both of those already and uploaded them to the data store in ESXi. I created an ISO directory for this, so we will find that and actually show the ABoot vEOS image here, and then the VS Lab image here, vEOS Lab 4.23.3m.vmdk. So we go back to our data center view, and we go through. We're not actually going to deploy an OVF like we did for CloudVision because those files are not packaged as an OVF or an OVA. So we're just going to create a new virtual machine, which is a pretty common VMware-based task that lots of people know about, and we'll go ahead and give this switch a name. We'll just call it PS-vEOS Leaf 1. So we'll go ahead and deploy this, and deploy it in the data store, compatible with ES 6.5 and later. Sorry, ESXi 6.5 and later. The OS family, since this is based on Fedora, is Linux, and then you give it the option for other Linux 64-bit. And we will put it on our management network. We'll give it 2 CPUs, and we'll give it about 8 gig of memory. And what we're going to do is, since there's already a pre-made hard disk for this, we're going to delete the one that's actually there. We're going to connect the ABoot device to the CD-ROM, And both of those files, both your CD drive and your new hard drive, have to be on the same IDE location. So we're going to put this one on IDE 00. We are going to emulate a CD-ROM, and we will find the ISO file for that, which we've put in the ISO directory as we said before. There it is. All right, connected power on. Okay, so he's ready to go. What we're going to do next is add that new hard drive. And we're going to say it's an existing hard drive. And we're going to add that and go back through and find our VMDK file. And there it is. Okay, so we have that set up. There's a couple of these things that aren't really necessary, but the way that it is right now is fine. It's going to go ahead and boot the way we want it to. So that's it. We will go ahead and hit next, and this is ready to complete. All right, so that's how we create our vEOS switch, and now what we'll do is go ahead and power it up. Power it on just like any other VM. So now we're going ahead and booting this vEOS switch. It is going to go through the process and show messages indicating status as it goes. So this is going to take a while, and we will speed this up so we don't have to wait too long. It went ahead and booted, and this is actually the default mode that both vEOS and EOS are in when you power them up initially. You can see that it says that no startup config was found, which means it's in zero-touch provisioning mode. And you can see where it says the device is in zero-touch provisioning mode and is attempting to download the startup config from a remote system. The device will not be fully functional until either a valid startup config is downloaded from a remote system or zero-touch provisioning is canceled. And then it tells you how to cancel for just this iteration, or you can disable for all future iterations, and it's just zero-touch is just disabled, and you could actually just configure the switch by hand, just like any classic CLI based configuration. So what we'll do now is go to the CloudVision portal primary node, and we will enable DHCP on that node, and we'll start the ZTP provisioning process. Okay, we are going to go into the process for zero-touch provisioning. At this point, we have a network provisioning screen. Oh, let me log in. Okay, so a couple things we'll go over. When we last left this, we only had the tenant higher level container and the undefined. So one thing to point out is that this is not a network diagram page. It is not a network topology. It is a hierarchical representation of all of the devices in their appropriate configuration containers. The lower you go in the tree, the more specific the configlets get. I've actually already set up some containers below the original one. I called the highest level one training, and you can actually change the name of that at any time by double clicking on the title underneath whichever container you want to change. So I actually I actually created these containers. The way that you do that is you right click on the upper container, and then you just say add container. So this would be new container. You just click OK. So what I did was, and then you save that, and it's there, and you can assign configlets. So I'm just going to delete that. I'm going to remove that, and it is gone. I've actually pre-imported some configlets. A couple of these are configlet builders. One is a device-specific configlet that will go directly into the device itself when it's imported. The rest are higher-level containers that contain things such as aliases and a new prompt command. Actually, it's not new. Something specific for MLAG, SNMP configurations, and those are going to go in higher-level containers, and our static users, which are admin and CVP admin initially. We will show you how all this works momentarily, but in the meantime, let's show you that the highest level container has no configlets applied to it, and then as we go down into the highest level, just data center container, we have all of these. We have the two configlet builders along with the aliases and the SNMP and static users, more specific configlets. And as you can see, the most specific device-specific configlet is not applied to that container, and it actually is not applied anywhere. So if we look at that list, we can see that the PS leaf-1 underlay only is not applied to any devices and is not assigned to any containers. So the whole point of this is to import a device that has just been powered up. Our vEOS switch that we built is sitting in zero-touch provisioning mode right now. So I will explain a couple things. This is actually the CLI of the CVP primary node. I have actually set up the DHCP service with a subnet, a range, and then option 67 boot file name, where the device will do the request, get an IP address from this range, and then it will be pointed to a directory that sits on the CVP, the primary node itself, where it contains a base bootstrap file. So we'll see all that happen momentarily. So what we can do here, and this is just standard CentOS Linux DHCP service. So we can take a look at that at the status, and we can show that it is inactive and off right now. So we'll go ahead and start that. And then we can see a status here. So it's already made an offer out to our device. There it is. So you can kind of see how things are progressing. And that was pretty quick, actually. So it got its IP address, it got its base configuration, and it is just sitting in the undefined container. You can also go back to the devices section and see that it is in our devices list, which means it is streaming telemetry. It has API turned on, and it is able to communicate with CloudVision, and CloudVision is able to communicate with it. So what we'll do is we'll go through this process. From CloudVision's perspective, it is ready to be provisioned. So what I'm going to do is start the process and do a move. And where I want it to go is into the Leaf Maintenance 1 container. Since there are builders that are assigned to the higher level container, it's asking me if I'd like to generate a configlet via the builders. So I'm going to say yes. So the first one is the telemetry configlet, and the reason that I want to actually create a separate one is the fact that the one The CLI that is in there now is not in a management VERF. So all we're going to do is create a new one that is now in the management VERF. So it has a builder, and as you can see, it's that same CLI. And likewise, we go down to the switch management. We're going to give it its host name, and we're going to give it a new address, because currently it's at 1092.64.135, but we're going to make it 242. So we generate that, and if we take a look at that, we can see that it's a management related configuration with the new address, and it actually puts the API into the management VERF as well. So we'll go ahead and update that, and then we go back in and we can add its final configurates to it. So it already has all of these applied that were in the higher level containers, except for its device specific, which is going to contain more configuration that is going to be unique to the device itself, and that we can't really put in a higher level container because it is too specific. Just like some specific addressing, its router ID, some loopback addresses, and those sorts of things. So the right side is what is actually running on the switch right now, where it says running configuration. The left side is the design configuration, which is the culmination of all of the configurates that you see here. So this is the design configuration, is what CVP thinks that the device's configuration needs to be, and the running configuration on the right is what it actually is. So what we're going to do here is we're going to push save, which means we're going to push from left to right, but there's some steps in the middle that doesn't automatically happen. So we'll go ahead and do that. We're going to hit save, and then you can see that it knows where it needs to go, and we need to hit save again. And when we do that, it creates a task and it sits it back in the undefined container temporarily. So we can go to the tasks from up here, or we can go to the left and do it from over here. So you can see that it actually created a task, but what we're going to do is create a change control with that task. What we're going to do is go ahead and review this change, and it kind of just tells you what's going to happen. It's going to send all of the configuration on the left over to the right, which is from CVP to the device. It's also going to do a check on the software version and upgrade it as necessary, but we don't need actually to do that because it's already on the correct software version. So we can review that and make sure that that's what we want to do with this. And as you can see, everything in green is going to be not necessarily like integrated with the current configuration, but it's going to actually do a white space overwrite. So everything that's on the device on the right side that is in red is going to be overwritten, and it's going to be deleted and then overwritten. So that's a good thing actually to understand. So we'll go ahead and approve it. And now we have the ability to execute the change control. So we'll go ahead and do that. And it gives me a warning that, hey, this is going to happen right now. Are you sure you want to do that? So we'll go ahead and execute it. And here we go. So we can take a look, and what happens is the switch gets rebooted, which takes it out of zero-touch provisioning mode. And we'll wait while this reboots. Just a couple of things while this is rebooting. Before, I had mentioned the image. So there's an image management section where you can create image bundles which contain both the EOS image or vEOS image, which also contains the Terminator version. We'll look at that closer in a few minutes as well. But while this is actually happening, you can check the progress and go back to change control, you can select that. Well, from there, if you just look at the overall, it shows that it's running, but if you select change control, you can actually look at the logs and it will update with progress. It is saying the EIP service is not reachable, and that's because the device is rebooting. So we'll let that happen and let it go. Okay, we can actually see that the change control has completed successfully. Yeah, it went through and applied the new configurates. We won't spend too much time examining that, but the key here is that our switch has been imported. And if we look at a couple things, it gives the serial number of the device, but it's pretty ambiguous because it's a vEOS. But it's got a system MAC and its IP address. So if we look at devices, we can see certain things about it. And this is actually linked to telemetry. Its version of software, its streaming agent, the fact that it got a new IP address. And we can go into telemetry and start kind of looking around. We can see that it's compliant. It shows the CPU and the memory. And we can actually look at the running configuration at any time. You can't really manipulate it from here. Not too much environment information on it because it is a vEOS device. But we can see that it actually applied all of the configurations, like our aliases, the correct terminator configuration with the VRF, management VRF, the a host name, all of the SNMP configuration. Now, the fact that there is only one switch here in our topology, the configurations that we're putting in aren't really doing anything as of yet. But if there were other switches here, we could check our neighbor relationships, our routing table, our ARP table, a lot of things. Look at different VMLAG configuration. It's showing that it's configured, but basically not working because there's no peer. So we won't spend too much time on this. The most important thing is that we were able to push our configurates that were in the hierarchical containers along with the device specific. So we can, if we want to take a look at those configurates, we could do the manage configurate and see all of these configurates are applied, and we can validate even further to go back to the view that there are no mismatches across any of the either side in the design configuration or the running configuration. So there's nothing to do here. So hopefully that kind of gives a general overview of how the general configurate hierarchy is set up, along with an idea of how to import these devices using zero-touch provisioning. And that is it.